Chris Lalancette, he's our last keynote speaker of the day. Chris is coming from Intrinsic. And Chris is going to be talking about the future and current state of ROS 2 and the future outlook of core features in ROS 2. All right, Chris, do you want this mic or do you want this one? All right, here's the clicker, all yours.
Thanks, Ramon. Hello, everybody. Yeah, so I'm going to talk a little bit different than what everybody else talked about so far. Right? None of this is going to be drone specific, but yeah, I really want to talk to you about ROS 2, right, and really give you some idea of where we're going and how that's going to affect all of you and the PX4 integration with it. So I'm the ROS 2 technical lead. And I currently work for Intrinsic. So as the ROS 2 technical lead, I'm basically responsible for making sure all setting the technical direction of ROS 2, where it's going, running the day-to-day of it, doing lots of reviews, and making sure the community is moving forward, and all of that stuff. If you've interacted with ROS 2, if you've done any pull requests or issues or anything like that, I am Lalancette on GitHub. You've probably interacted with me in the last 7 years. So what I'll talk to you about is a distribution update, just to give you an idea of where we are with ROS, what's supported, what's not, a little bit about how we do the releases. I think that touches on like what OpenCV said and what PX4 said, just to give an idea of how we do it. Talk about features and development for Jazzy. This will be really important, particularly with some of the stuff talking about micro DDS. And then the long-term outlook for core features. All right, so for the distributions, you can see on the slide, right, along the top we have the end-of-life dates for our distributions. In the middle there we have our distro release dates, and then at the bottom we have rolling. And the way that this works, right, is rolling is a fully installable distribution on its own, but it is rolling all the time, right? Features come and go, APIs might change, and all that stuff. So you can always install it. It really shows where ROS 2 is going to be for the next release at all times. And then periodically we freeze rolling, we branch off a distribution, and then that's the next stable distribution. In the next slide, though, you'll see what is currently supported, right? So right now, for ROS 2, we support Humble, which came out in 2022, and Iron, which just came out in May of this year. One other important thing to keep in mind, I don't know how much it matters to this community, but Noetic is our last ROS 1 release, right? That is supported until 2025. After that, all support for ROS 1 will be completely community-based. So if you're still using ROS 1 for anything, please, you have about 1.5 years of transition. Really think about starting that transition. All right, so now I'm going to talk about the release process. The release process takes about 400 days. That's from starting from the naming all the way until we press the big red button to do the release. And we have about 40 steps. This is actually brand new, where we just sort of opened up all of the steps with really a lot of details on how the release is done. We've always had this internally. This is how we've done the releases for years, but we've opened this up so that really people can get a better idea of how this goes. So I'm not going to talk. I don't have time to talk about all those 40 steps. It takes quite a while, but I'm going to talk about how we do it in sort of a very condensed form. So we have I'm going to talk about 10 steps today. First of all, we name the release. This is maybe not that interesting, but it's part of the fun of ROS development, right? Which is we get these names. So we send out a post on Discourse. We get some ideas from the community. Actually, we get a lot of ideas from the community, and then we compile that list. And the ROS 2 core team then goes ahead and votes on the different options. And we have to eliminate some, right? We can't take things that are copyrighted. No Ninja Turtles, unfortunately. Things like that. And eventually, we have a ROS boss. So while I'm the ROS 2 technical lead, we also, for every release, have the ROS boss, who's responsible for the mechanisms of doing the release, running the release team, things like that. So obviously, I work very closely with the ROS boss every year, but the ROS boss is the one who ultimately chooses the name. And I think I didn't mention, but we have an alphabetical order, right? So we Iron or Winnie, we have an adjective turtle species, and then it's Jazzy Jalisco, and then whatever K turtle is going to be. Next up, we develop a release timeline. So this is somewhat redundant with that list of 40 steps I showed you at the beginning, which are also have times, but that is really, really detailed, right? For most people who are in the community, they don't need to know all of those details. So this release timeline that we always put out in about the summer before the release is just the very important dates for everyone to follow. So I'll get into a few more of these, but like these are the ones that if you're releasing code into ROS 2 or you want to do feature development or anything like that in ROS 2, these are the dates you really need to meet in order to get your stuff in. This is an important step, is the migration to the next Ubuntu. So this only happens on even years, right? We only do an update onto LTS Ubuntus, which are supported for 5 years, and that happens on even years. So as soon as the next Ubuntu alpha packages are released, so it'll be in about December, maybe January timeframe, we will transition rolling onto that new distribution. And that, since Ubuntu is our primary platform, right, that's the most important migration we do. So we'll get the binary packages over so you can install ROS rolling on Ubuntu 24.04, and of course all our CI will also move over. We also have a logo. This is the other fun part of doing ROS 2 releases. I make it sound like the rest is just chores, but you know. The other fun part is we always have a logo, right, that goes along with it. So we have an artist, Joshua Ellington, who's done all of our ROS art for many, many years now, including the ROSCon shirts. So we give him the release name, we give him a few ideas we've come up with, what we think it might be. He comes up with some sketches, and then we'll vote on those options, and then he'll finalize it. And the other like small thing that happens here is that we have Turtle Sim, which is our tutorial-based simulator, and we have a little turtle that goes along with that. So that's all sort of the preparation work, right? That's kind of the fun, easy stuff. Now, this is when we get into the freezes, or the real work of the release. And the RMW freeze happens about 7 or 8 weeks before the actual release. So we announce this on Discourse. And if you're not familiar, the RMW is the ROS middleware. This is the abstract API we have between what the middleware is, so that's your fast DDS or Cyclone DDS or whatever it is, and the rest of ROS, right? And this is purposely an abstract interface that is not tied to any particular middleware. But of course, the middleware is sort of the heart of ROS 2, and so we freeze the RMW about a week or two before we freeze everything else. So the freeze means no new APIs into that RMW or no new changes to that API, no new updates to the middleware vendor packages themselves, FastDDS, Cyclone, et cetera, and the implementations that translate between them. We'll still accept bug fixes, but no new features and no API changes. And then again, about a week or two later, we'll do an overall freeze. This is the same rules, right? This is freezing all of the core of ROS 2, so that we won't accept any features or APIs or anything like that into any of the core at this point. Bug fixes will still be allowed at that point. Again, same rules. And then once that's done, the big reason we do that freeze is so that we can then release the core into rolling. And to be clear here on this step, we were releasing the core into rolling. Up until those two freeze dates, lots of activity is happening, right? This is when everybody is scrambling to get all their stuff in, so lots of new code has poured in at the last minute. So we release all those changes into rolling again to make sure that rolling still works, right? That everything we had before still works. We'll do smoke testing on this. We'll tag the sources. We'll make binaries out of it. And that gets us into the branch. So this is the point at which we branch off of rolling. So we'll branch the sources. So every repository has a rolling branch. It will now also have, this year, a Jazzy branch. Once we've done that, we will open up rolling for changes again, right? So this is how rolling is only frozen for about 2 weeks every year. Other than that, rolling is always moving along. And once we've done this branch off, we can open rolling back up. We will create, this is also the time we start creating the binary packages. So you can do, instead of apt-get install ROS rolling desktop, now you can do apt-get install ROS Jazzy desktop. And if you've done any releases into ROS 2, especially rolling, the release repositories all have to be in this ROS 2 GBP repository, and that's because in order to do this branching off, we have to have write access to all those repositories, so they all need to be there. Yeah, we'll go from there. So this is a new thing that we did in 2023, which is the tutorial party. This is an idea we took from the Gazebo team, and this really includes the community in the testing. So basically, we generate this list of test cases. This year, it was about 450 test cases. That's based on our tutorials, based on some handwritten things, and then every single one an issue is created for, and that's across. We do that across different platforms, right? So we have a matrix of supported platforms, supported operating systems, different DDS vendors, et cetera, and people come in and they assign themselves to an issue and they test it and they find out, oh, this is broken or this worked fine, and we close the issue. And this allows us to make changes to the code, of course, make any bug fixes, to documentation, to the tutorials, anything like that. So we had great response this year, right? We had 40 unique testers, and we tested, of those 450, we tested about 440 of them. So this was a great success, and we're going to do it again. And then finally, we get to the release, right? So on the release day, we mark the distribution active. We move the binary packages up to this point. They're in a testing repository that people can install from. We move them into main to signify that they're ready. We tag the sources, and we announce on discourse. So yeah, so that's just a brief overview of how we do the releases. I don't know if any of that's helpful for the rest of you trying to do releases, but yeah, that's how we're doing it. Now I want to talk a little bit about features and development for Jazzy, and in particular one that you might have seen. So I know it has been mentioned that PX4 just introduced micro DDS support. So in ROS 2, we are exploring some alternatives to DDS. So before I go any further, I'm going to say, DDS is here to stay in ROS 2. ROS 2 has always been built on DDS, and it's going to have, for the foreseeable future, it's going to have DDS compatibility. However, there are some issues with DDS, and we think that there's a place for another middleware that's easier to use out of the box. I'm not going to go into too much depth about all of this. So those two links there, and the QR code in particular, we did a lot of work over the summer to sort of investigate what are the problems people are having, what are the alternatives that are available out there, and then we wrote this report which sort of does a cross matrix between that, and to try to find what a new middleware that might solve some of these problems. So after doing all of that, we came up with Zenoh, which is a new, relatively new middleware out of Zettascale as a potential, new thing. And so the big development thing we're doing for Jazzy is to develop this alternative RMW. Besides possibly making it easier to get started, the other reason to do this is that RMW API I talked about. If you only have DDS, and which we do today as the RMW, while it's meant to be abstract, those details can leak through it. So having another RMW that's not DDS in there can really help in making sure that's an abstract interface. So for Jazzy, the goal here is just to have it be a source installable RMW. We'll have a source repository. You'll be able to download it and build in a workspace, et cetera, et cetera. For KTurtle, the goal will be to make it a tier 1, and so it's installable with apt-get install RMW Zenoh. And then a long-term outlook for core features. These are features that have not been committed to for ROS 2 on any particular timeline, but they are things that we think would be helpful for the community in general. So I also welcome any of your input on things that you're missing in ROS 2 that might be helpful. So first of all, I don't know if anybody in this room uses Windows, but we do have users in the community who use ROS 2 on Windows, but it's kind of a challenge to install and to maintain right now. So Conda, if you're not familiar with it, is a cross-platform packaging service, and it's very equivalent to apt. You can do like Conda install, whatever. And so first of all, we can use it to install our dependencies, and second, we can use it to possibly release all of the ROS 2 packages. So, we have packages, anybody in the community can release packages into ROS 2, and we'll build Debians for Ubuntu, we'll build RPMs for RHEL. We could do a similar thing with Conda, where we build Windows packages via Conda. And in point of fact, there is a group doing this called RoboStack already, but, we want to have tighter integration with them so that, things move along nicely. Performance improvements, right? This is things people always want. In particular, we know that RCLPi has some performance problems for delivering messages and things like that. We also know that the executors in both RCLPi and RCLCPP are not as performant as they should be. And if you're not familiar, the executor is the thing that actually calls your callbacks on subscriptions and services and things like that. So it's the thing that looks for events happening, and then when they happen, actually invokes your callbacks. So yeah, performance improvements, this would be really good. We've done, of course, this over time. It's not the first time we've done this, but everybody wants this. The ability to release Rust packages, of course, this is very topical. People are talking about Rust a lot in the ROS2 community. So, but right now we have no way to actually release them, so you can install them. So this is an important thing. It will also be important to make Zenoh a tier 1 RMW. Evolving messages over time. This one, if you've ever done like serious development with ROS2, right, you've probably taken a bunch of bag files and collected data using a certain set of messages. But during development of during playback of that or debugging of that, you might find that, oh, you need to change those messages. And now your bag files are obsolete. So what the evolving messages over time feature would allow you to do is to write translators between that old message and the new message, and those would be invoked automatically, appropriately at runtime. We did some of the work for this in Iron, actually, but it's actually a complex feature, and so we've just sort of did one major step of 3, and so this is one that we think would be really helpful. And then another one is how to automatically detect the best way to deliver data in ROS2. So RCLCPP in particular there's lots of ways to configure it. You can use composition, you can use lone messages, you can use inter-process. And depending on how you're running and deploying, some of those are better than others. And it is possible to make a really performant ROS2 system, but you kind of have to know what you're doing and how to set things up. So we want to make that a lot more automatic, right? And have RCLCPP in particular tell like, okay, if this is in the same process, I'm just automatically going to use inter-process. Or if it's on the same machine, I can use shared memory directly. These kinds of things. So we want to make that a lot more automatic. We'll always leave the knobs so that you can turn it on and off yourself in case you have particular needs, but we want to make it smarter out of the box. This is a list of resources. So that QR code links to like sort of the main page of our documentation, which has all the resources to get in touch with us, right? So if you're interested in helping with any of those features, or those features are interesting, or you have new features that we've not listed here that would be helpful for you, we'd love to talk about it. You can come talk to me. I'll be here for the conference, but you can also get in touch with us via all of these mechanisms here.